Alright, ladies and gentlemen, time for some worked examples from your Probability and Calculating Independent Events assignment. I'm going to work through a few of these just to kind of help you out. I'm going to do kind of these beginning ones and then some from the back side there in hopes of helping you out. So make sure you have your assignment handy and you can follow along. A few things I want to point out here in this Venn diagram. This 27 means there's 27 girls in Miss J's class that don't participate in sports. And then there's 27 girls who do participate in sports. And if you're going to get any of these probabilities, you're going to have to figure out how many there are total, which is actually going to be adding all of these numbers together. So Miss J's classes, there's plural of them, and it's going to be quite a bit. So just pause it, add up how many they are. And I got 100 total. I also want to mention that this 11 here means it's not girls and not participating in sports, which will mean these are boys, not sports, not participating in sports. Which will mean this 35 here are boys participating in sports. So there's a few things to know about the Venn diagrams. It's kind of hard to read, but hopefully that'll help out a lot with these questions. And in fact, you should take a moment to pause and let's have you do the first two. Actually, let's have you do the first three here. Get the first three probabilities. The comma here is going to act like the and symbol. So this is sports and not girls as you go through here. So try the first three, pause it, and we'll come back and check and see how you did. Alright, let's have you check and see how you did. The first one here is figuring out the probability of girls. That's these two added together. So it's 54 girls out of the 100, which reduces a little bit to 27/50. The next one is probability of sports and not girls. That's going to be this group. So participating in sports but not girls. Remember, these are all girls here. So that's going to be boys who do the sports, which is 35 out of 100. Again, reduces a little bit. And then our next one is just probability of not sports. That's everyone outside the circle. So these people, which is going to be the 27 plus 11. And that's where this 38 came from. And 38 out of 100, again, reduces a little bit. So hopefully that's making some sense to you. Let's see if you can try out the next three. And we'll come back and check and see how you did. Pause the video. Get it done. So these three are actually a little bit easier than the ones above it if you can read your Venn diagram. So this one got probability of sports, and not girls. That means boys not doing sports, which is just this group here, right? Not girls is all of this, and then this is the sports part, and so you take that part out. You got the 11 out of 100 there. The next one is girls and sports, which is conveniently the middle of our Venn diagram. Girls participate in sports. And the last one is just probability of Mrs. P's classes. Oh, wait, that says P. I got that wrong. No. Yeah, it says Mrs. P's class, and this is Miss J's classes. So none of these people's are in Miss P's class, at least that we know of. And so we got 0. If you pick a person from Miss J's class, are they in Mr. P's class? It appears to be no. And so there's that. Let's go on to the back side here. This is where we'll be talking about independence to kind of review that for you. So on 17, you got these two events, probability A, probability B, and probability of A and B. And we're trying to figure out if they're independent or not. Well, you're going to use your lovely little formula. Two events are independent if the probability of A times the probability of B is equal to the probability of A and B. And so we're going to actually calculate that. We'll get, well, let me do it right below. You got 0.7 times by 0.3. And we're trying to figure out if that's the same as 0.21. In case you didn't know, you can take those decimals and actually just put them in your calculator and figure it out. So left side, 0.7 times 0.3 does give you 0.21. Is that the same as 0.21? Never mind. Yeah, they're definitely the same. Those are the exact same numbers, and so, yes. And it's going to be because of this thing. Like, you just write that there. the probability of A times the probability of B equals the probability of A and B. Like, that's the mathematical proof for why two events are independent. But let's go to 18 and use this kind of information, kind of like real-ish life. You know, Jaren's got a dozen cupcakes. I don't know why, but he does. He's got cupcakes. Maybe he's got a party, and he's supposed to make them. But would you really trust a guy named Jaren to make your cupcakes for you? I don't know, but we'll see. Anyway, there are 3 chocolate with white frosting, 3 are chocolate with yellow frosting, 4 vanilla with white frosting, and 2 are vanilla. Oh my gosh. That's a lot of information. What you may want to try is just make it into a little table. That helps me organize my thoughts, and it helps me kind of figure out what's going on. So we got chocolate and vanilla cupcakes, and there's white frosting, and then there's yellow frosting. Here, I'll call this choc and van. Let's see. We got 3 chocolate with white frosting, 3 chocolate with yellow frosting, 4 vanilla with white frosting, and 2 vanilla with yellow frosting. Let's get our totals here. We got 7 white, 5 yellow, 6 vanilla, and 6 chocolate, which means there's 12 total. So I highly recommend you turn this into a lovely little table so you can have it handy, and you can use these numbers to help you calculate things like, are the cake flavor and frosting color independent? And the way you can figure that out is, well, you do this. You need to figure out something you want to test. Let's say we test this guy here. Is the probability of vanilla and yellow frosting equal to the probability of vanilla times the probability of yellow? Well, let's just test it out real quick. You'll have probability of vanilla and yellow. That's 2 out of the 12. I'm not going to reduce that for a moment, just so we can kind of see it. And you got probability of vanilla. Well, there's 6 of them that are vanilla, so 6 out of the 12. And then probability of yellow. Well, there's 5 of them that are yellow out of that group there. And we're going to see if these are the same. So just take a moment, put those in your calculator, and get what those decimals are and write them down. Pause the video, get it done. Alright, let's have you check and see. On the left side here, you should have gotten 2 12s, which comes out to be 0.167. And on the right side, you should have gotten 0.208. These are not the same. They're not within like that 1% difference. And so we can say, no, they are not independent. And there you go, some worked examples for you. The end. Good luck. Get her done. All that wonderful stuff.